Hello friends, good evening to my dear students. Today on continuation of estimation of power lines. So we are already estimated the 11 kV lines with different configurations. After that, now we are going to estimate the given low tension distribution line as per problem given factors. Today is very easy and everyone has to know, because this power has to used in everywhere, in domestic, in commercial, small shops also. So as an electrical student, we should know how to estimate the LT line materials, its cost. Let us, myself, Dr. C.H. Chadaya, Senior Lecturer in Electrical and Electronics Engineering, Government Polytechnic, Husnabad. Today topic regarding to diploma students 5th semester C18 scheme EE 505. Let us see today topic, and on completion of this topic you would be able to know the introduction to power system line configurations, salient points of distribution system, and finally we are going to estimate the quantity of all materials required for a given low voltage overhead distribution lines as per standard practice. So before going to estimate the LT lines, once again we will recollect what we have learned in power system. What is the distribution lines? What is the power system lines? How to power comes from generating station to load center? Let us see one by one in details. Now you can see this power system diagram where the power is generated by conventional and non-conventional energy sources. That energy generated is a low voltage, that is a less than 33 kV. The 33 kV voltage is stepped up by power transformer at generating stations. The less than 33 kV voltage step up to 400 kV or 765 kV voltage, that is transmitted to nearby load centers. You can see the 3 transmission lines you can see. After that it comes a receiving station nearby a metro city, where once again 400 kV to step down to 220 kV one substation, and 220 kV to 130 kV in another substation, where 130 kV consumers also available. Generally directly we will give to the one feeder to railway department, where they will take the directly 132 kV lines, HT lines. Next 130 kV line once again step down to 33 kV line, and the 33 kV line is transmitted to the thickly populated areas, where a small 33 kV by 11 kV substations erected in the city. From that 33 by 11 kV substation, number of feeders will go to the number of different areas to cover as 11 kV lines. This 11 kV lines, you can see here the distribution started here, distribution substation. From that one area it is covered to a domestic, and another area you can see a small factory and industry. That means here, so how to classification of this power system? The power system classified based on different factors, mainly primary transmission, secondary transmission. Next, the primary distribution and secondary distribution. Let us see one by one. Now you can see the once again how the voltage is step down from high voltage to low voltage. Here power generating station, a generator transformer step up to the 400 kV. Low voltage generally generated in generator due to the insulation problem, and that 400 kV is transmitted to a long distance by using the long transmission lines. Once again, it is a step down to the nearby metro city 275 kV. I think it is not possible in our India. So we are generating 400 kV, we are transmitting the 400 kV and step down to the 220 kV. And 220 kV, after that it is once again another by using the transformer, it is 275 kV to 130 kV is step down. In our case, we are 220 kV to 132 kV step down by using the power transformers. And from 130 kV to, so another by using the another transformer, so step down transformer, so it is step down to 33 kV. Here you can observe is a heavy industry, large factories. For example, in case of city Hyderabad, so BHEL will take the directly 130 kV line, and railway department at Gatkesar, they will take the 130 kV line for traction purpose. And after that it will go to the 33 kV lines, and the 33 kV lines also some companies and factories will directly take the 33 kV. For example, Ashok Leyland at Uppal, and some factories, major factories will take the directly 33 kV lines also as a feeder input power. They will have their own power transformers to step down for their different applications. Then next, here you can see the light industry, they will take the directly 33 kV also, sometimes they will take the 11 kV. After 11 kV, so it is once again, so this step down to the DTRs, where it is a 3-phase 400 volts and single phase 230 volts, that is given to the normal domestic applications. These are the some idea how the voltage from generating station to nearby our house, what are the steps to converted voltage from low voltage to high voltage to step by low voltage. This is a total overall power system transmission system. Now if you are seeing as a student in line diagram, so here, so we are going to learn, so let us now this line diagram of total overall power system. What we have seen as a diagrammatically we have seen. Now it is as a student we should know the single line diagram of power system. Now you can see the from generating station to nearby small domestic. Extreme left you can see the primary transmission system, that is the primary transmission lines. So that is nearly 130 kV line. So that 130 kV line, so directly given to the is a 132 kV by 33 kV substation, that is known as the primary substation. This primary substation, so it will take the input as a 132 kV and step down to 33 kV. So as already I have said, so 130 kV input also taken by the railway people also. So they will have their own substation. After that it will, so 33 kV is transmitted to the nearby secondary transmission substation. So where, so 33 kV by 11 kV another PTRs provides, they will convert, it will convert 33 kV by 11 kV. So from primary substation to secondary transmission substation, so there is a line, that line we can set the secondary transmission system, that is the rating of 33 kV. After secondary transmission substation, so next the primary distribution substation, where 11 kV by 400 volts, that is nearby our street DTR. So that line is known as primary distribution line. 11 kV line is nothing but primary distribution line. Now we can see here the feeder F1, and after that, so here sometimes bulk consumers also will take the 11 kV as an input. Some you can observe the rice mills and oil mills and cotton mills, they will directly take 11 kV as an input for their factories. Next, the 11 kV by 400 kV DTR step down to the 400 kV, and that is given to the different distributors D1, D2, D3. So here that is line is known as a secondary distribution lines. So that is the, we have to remember that. Here what is the difference between the feeder and distributor? We can observe the secondary transmission substation, that is the 33 kV by 11 kV substation. After that F1, that is the feeder. What is the feeder? The conductors which connect substation to the areas served by these substations. That means it has no tappings. So only the conductor is from substation to nearby substation, that is the transformers. It is designed based on the current rating only. Whereas distributors, you can see the D1, D2, D3. So these are the distributors are the conductors from which the number of tappings have taken for different consumers. So D1, D2, D3 taken output of the 11 kV by 400 volts substation output, we called as a distributors. What is the distributors? Distributors is nothing but the conductors from which the number of tappings have taken for different consumers. Here, so current is not constant, and it is mainly designed based on voltage drop. These are the things you should know, the feeder and distributors. Before DTR input, that is known as feeders. After DTRs, we can say the distributors. The feeders is designed for a predefined current rating of line, and there is no tapping in between. But whereas the distributors, it will take the number of tappings, and it is mainly designed based on the voltage drop of the line. So these things you should know. Now after that, we are going to now what are the classification of distribution systems. So how many types of the distribution system classified? So mainly the distribution system is classified into the two types. One is a primary distribution system, another is the secondary distribution system. The primary distribution system is nothing but it is the with 11 kV supply to the consumers, whereas the secondary distribution is given the 400 volts 3 phase and 230 volts single phase given to the consumers. These are the main things you should know. Now what is the actually distribution system presents? You can see similar to the power system, you can see here is the one figure distribution system. So the distribution system you can observe from different stages of this one, where one factory directly take the voltage, that is the 11 kV that it will directly takes. After 33 by 11 kV and given the 11 kV feeders is coming to the commercial building and some other areas where once again step down to the 400 volts, they will take the domestic also. These are the overall idea of distribution system. That means the whatever the energy generated in genetic plant is given to the consumers by distributing this energy to the consumers based on some predefined tariffs. Distribution of energy to consumers, that is our aim. So that is a thing. Now to distribute the generated energy to the consumers, we require some lines. That lines how we are going to estimate, that is our aim today. We require to estimate a line for example 1 kilometer of the LT line. What are the accessories required? How to calculate number of main components, what is the cost we are going to calculate. That is our aim today. Before that one, we should know some basic points of distribution system. So let us see once again this one. Now, so what is the primary distribution system? Already we have seen that the primary distribution system is nothing but it is before, that is before 11 kV by 400 kV substation is the primary distribution system. After that is the secondary distribution system. Here secondary transmission, not distribution. Secondary transmission before 33 by 11 kV substation, the secondary transmission substation. And next, so here primary distribution, and here is the secondary distribution. I think you have some idea what is the primary distribution and secondary distribution. So for a clarity, you can see once again here. So here the primary distribution also, the bulk consumers they will use. So you can see here another figure for clarity. You can here one is a generating station, extreme left, and generating step up transformer. They are used in middle, and that is a step up to the 765 kV voltage, high voltage, that is given to the transmission customers, where 130 to 38 kV to 230 kV lines, that is transmitted to the nearby substation. The substation step down once again power transformer to the required voltage. Here required voltage one is the sub transmission. So where the customers they will take the 26 kV to 69 kV, one first top figure. Next another the line where is the primary customers, the 13 kV to 4 kV, and next after that once again they will use the secondary customer, so 120 kV to 240 kV by using the single transformers we can observe here. So this is the overall idea of transmission system. Now after knowing the primary distribution, the primary distribution is nothing but the majority of the consumers they will take directly some paper mills and rice mills, and whatever the directly some small factories also they will directly take the 11 kV. So that is known as the primary distribution system. After knowing the primary distribution system, let us see the secondary distribution system. What is the secondary distribution? Here you can see the line diagram. This is the secondary distribution system. This is the first primary distribution before that one, and now secondary distribution is the what is one after DTR. So we are going to say that the secondary distribution system. What we are going to connect? So it is connected to the different consumers based on the distributor 1, distributor 2, distributor 3. So distributor 1 may be the bulk consumers, agriculture, domestic, different consumers. So this is a basic idea of distribution system. Now let us see the physically. You can see the here same system here, primary and secondary, and this domestic loads where we are going to give the houses, and same supply is given to the commercial loads in the complex, that is the shutters, shopping complexes, we can say the commercial loads. At the same time it is also given to the small industries. These are the loads connected at secondary level. So these are the basic idea of primary distribution and the secondary distribution. Primary distribution, what are the loads, and secondary distribution, what are the loads. Now we have some idea. Now first of all, as per what do you mean by the how the distribution system is classified, what are the different types, what are the factors to classify the distribution system. Let us see. And here the distribution system is classified based on the different factors. The first factor is the type of current, which type of the current you are going to use. That is you can see here, this is the type of current, which type current, whether you are using the AC current or DC current, that is a type of current. And next is the construction. That means, so construction means you are going to you can give the supply to the consumer by overhead line or underground cable, that is based on the construction. Now another thing is another factor is the service. Here service is given to the which consumer, you are going to give that for the domestic, or you can see the, you are going to the, okay. So here service, what do you mean? Services, the domestic services, industrial services, and railway services, and street lights, and schools, different services. That is the service oriented. And next is the number of wires. So number of wires means, so the line may be consist of the single phase 2 wires, and 3 phase 3 wires, and 3 phase 4 wires sometimes. 3 phase 5 wires also. That means R phase, Y phase, B phase, neutral, another is the street light. This is the, so based on the number of distribution system classified based on the number of wires. 2 wires, mainly 3 wires and 4 wires. That is the one thing you have to remember. Next is the scheme of connection. That means, so whether you are connecting the line, which direction, whether it's a radial connection, a ring main system, interconnect system, these are the different types of system. Let us see in figure. Now, what is the type of current, whether AC current or here the DC current. Generally, here the AC in government, they are supplying the 230 volts single phase, 400 volts 3 phase AC supply they are giving the each and every consumers who required. After that, all electronics equipments worked on the DC supply. So whatever the AC is given by the government, that is converted to the DC inside the some rectifiers. So majority the what we have seen outside the LT lines, HT lines, or majority of except HVDC lines. So maybe R lines are the alternating current transmission and distribution lines. Now coming to the construction, that is the overhead lines. By using the service wires, we are using the overhead lines on the top of the tower to our house, and if it is not possible, then we can use the cable. So that is the underground cables. Service means is whether you are going to give the domestic service and industry purpose, railway purpose, and street lights are different consumers. And number of wires, 2 wires, 3 wires, 4 wires. Schemes are the how you are going to give the distribution lines is a lay on the thickly populated area. Whether first one is the radial, it radiates only one direction. Next, another is a ring main system, it is connected to the ring. And what is the parallel also, at the same time the distribution lines also run on parallel. And another is the interconnected system. These are the some configuration of distribution lines in normal days. Let us see, so in single line diagram, what are the radial system, what is the ring system, what is the parallel system, how the current will flows, how the reliability to the consumers, what is the benefits. Let us see at a glance. Already you know this thing, but let us see. Now, so before that one, so here you can see the radial feeder. So what is the radial feeder? Here the radial feeder is nothing but it radiates only one direction. So from you can see the 33 input is coming 33 kV by 11 kV substation, and after that it has a number of 3 feeders, that is 11 kV feeders, and one feeder is given to the our DTR, that is mentioned here red color, 11 kV by 400 kV substation. After that it is given to the different distributors. Distributor 1 3 phase 4 wire line, distributor 2 single phase 2 wires line, and distributor 3 3 phase 3 wire lines. These are the radial feeders. Now you can see here the power is ready at the 33 by 11 kV substation, and after switching closing the circuit breaker, it is coming to the our substation, and after closing the air brake switch, AB switch, then it is going to the our distributors 1, distributor 2, distributor 3. It is a continuously only single direction only the power is going. So this is the radial configuration of distribution lines. So what is the disadvantages? If one line fails at any places, total system is a collapse. That is a disadvantage of the radial system. But it is a majority of the lines are the this only. So this thing you have to remember. The simple and cost is very less, and voltage drop at last consumer may be affected, and not reliable system, because one line at suppose for example in 400 kV that 11 kV by 400 volts nearby this DTR fails, distributor 1, distributor 2, distributor 3 all will may not be get the supply. This is a single radial system. So we call this is a radial system. Now after that we will go to the second system. What is that one? Parallel feeders, where the parallel feeder, you can observe here, the feeder from the 33 kV by 11 kV substation and 11 kV by 400 substation, between one feeder and feeder 2 is connected in parallel at starting and ending. If feeder 1 fails due to some problem, then the power is supplied to the 11 kV by 400 kV substation with the feeder 2. That means, so uninterrupted power supply given to the distributor 1, distributor 2, distributor 3. That is the, here is a reliable system, the very reliable system. So you can see the animation, the power is coming here, and after that what will happen? So once it is closed and it is the power is going to the, so two sides. So here is a one feeder, and if it is required, it is going to the second feeder. The continuously giving the supply to this one. If feeder 1 problems, the supply may be continued through the feeder 2. If feeder 2 problems, the power is going through the feeder 1. So such a way we are going to get the uninterrupted power supply to our consumers. This is a one thing you have to remember. Now after that, another is a ring main system. Now, so name itself, it is a ring, that is a connector. Here 33 kV by 11 kV substation is connected to the one ring shape system. From that one it is connected to the all DTRs. Now what will happen? So the power 33 by 11 kV power may come to the our 11 by kV by 400 volts substation in the center one, may get the through the feeder 1 through the feeder 3. So that is a benefit. So that is a thing. You can see the animation here. Now the power is continuously on the ring. So that means, so supply is always here. So either side at feeder 3 or feeder 1 side, the if fails, automatically the power may goes in another direction. That is a ring system. So this is a very reliable system, and the voltage drop may not be occurred, very low value. This is a one thing you have to remember in ring main system. And another one is what you have seen, last one is a interconnected system. Let us see that is also. Now in this case, in the interconnected system, what we have seen here, the more than one generating station connected to the network. That means one station TPS, thermal power station, one station hydropower station, one station nuclear power station, that is nothing but power grid, and one may be non-conventional energy sources, that the wind power is connected to the our network. Our network is connected to the different the feeders. You can see the feeder 1, feeder 2, and what will happen? It from the feeder 1, feeder 2, it is going to the different DTRs. From DTRs to it is going to this one. If any problem occurred one generating station, automatically that is cope up by the another 3 stations. That is known as a interconnected power generating stations. We can say the power grid. So that is a benefit of this one. You can see here TPS is supplying the power supply. If suppose load is increased further, then unable to meet the TPS, thermal power station, then it take the help from the HPS. Then HPS will gives some more energy from the HPS. Even then if we increase the load, then it is connected to the NPS. Even then if we increase some load, then we are going to use the wind power generation. So such a way that we can cope up the load demand of consumers in interconnected system. That is a benefit of this thing. Now after that, so we are going to get now classification of further distributor. Now we have seen that how many types of distribution system. In distribution system, how the feeders are configured, and after that what are the distributors. Now after 11 kV by 400 volts DTR, the secondary side we can say the distributors. Now what are the different of the distributors, how these distributors are classified? Let us see. Though these distributors are also classified based on the different factors. What are the factors? First factor, loading. That means, so whether you are loading on distributor, whether the concentrated load or distributed load. Distributed is a uniformly loading, or concentrated is all load is only at a time, at place, some place. That is known as the classification of distributor based on loading, whether loading is a concentrated or whether load is distributed throughout the line. That is the one thing. Now we can see on other is a feeding. That means, what is the meaning? Feeding from the at one end. You can see here. Okay, loading is the concentrated and distributed, and feeding is fed at one end. You are giving the supply to the only one end, whether you are giving the supply to the center, whether you are giving the supply to the both ends, whether you are giving the supply a ring main, similar to the previous case. So based on this one, so we are having the different type of the distributors nowadays in present situation into thickly populated area. Whether the line is distribution line is fed one side, only one DTR, whether the line is connected to the two DTRs from the two different places, or so one line is connected to the it is radiated one side and radiated other side, center feed and ring main system. So different configurations are used in our nowadays in distribution systems. Now let us see the what do we mean with the fed at one end distributor at a glance. You can see this one, same figure. So here you can observe the red line that indicates we are giving the electrical supply, that is the 400 volts to the line, where I1, I2, I3, I4, I5, I6 are the connected to the consumers. There is one consumer having the load of I1, another consumer having the load of I2, another consumer having the I3. Similarly, there is a different service lines. Now, if the supply is given to the starting, what will happen? You can see here. So it is going to the directly on the feeder from this place to that place. So what will happen? So automatically, so all consumers will take the electrical energy from different. So this is known as the feeder, the distributor fed from one end only. So this is one thing you have to remember. Now next is the fed from the center. Name itself is center. Here also you can see the center. What will happen? So it is giving the supply here, and both it is going to supply this direction and it is going to this direction. Then automatically the all feeders will take the all service lines will take the electrical energy. So these are the one thing, the fed from center. It is going to this direction and that direction. Next, another is the fed at both ends. So what will happen in first case? So only one fed at starting. So where the consumers connected, they will get the high voltages. Their bulb will glow at bright. The line, the consumer who is connected away from the source, that is the very extreme right side, then he may not glow its tube light in his house. Tube light requires some 230 volts. Due to the long load, that is a long distributor, voltage drop may be more. At starting, we are going to 230 volts. Some after going to the extreme right, the voltage may not be 230, it may be 200 or 180 volts. Then in single phase motors may not work properly by using low voltage. That is a disadvantage. To avoid that one, we enhance it to the center fed. After that, so we enhance it to the double fed. You can see here the F1, F2 are the two supplying feeders. We are connected to the F2 one distribution transformer, and F1 also we are connected to the two distribution transformers. What will happen? There is no extreme sides. So it is a feeding here, it is a feeding here. So uniformly the voltage drop occur may not be large in this case. This is the one thing. Next, you can see the another is the ring main system. So what is the ring main system? Here also this is connected to the ring. That means, so whatever the energy comes, that is circulated in the ring continuously. So you can see here the I1, I2, I3 continuously will take the supply from the ring. So this is a ring main distributors. These are the classification of distributors based on its configurations. So you can see here. Now let us do these are the basic things what we have learned previous classes. Now, so based on this idea, now we are going to estimate one line for a half kilometer line in my village. I want to with one line, so I want the single phase or three phase lines, R phase, Y phase, B phase and neutral 4 lines for a cement poles, PSC poles. So I require the half kilometer LT line I want to erect. What is the cost of the material? How many poles is required? How many insulators is required? How many stay wires are required? How many accessories required? So these are already we calculated 11 kV similar to the LT lines. But in LT lines we are here neutral wire is another one wire. Now, so before this one, let us see once again what is the LT line, what is the component. This is the support is required and this is the cross arm is required, and next we require the insulators LT. We are using the pin insulators for the normal running. At corner, at end we require the shortly insulators, and we require the conductors, ACSR conductors is required. Now we require the stay wire is required, stay set is required, and if it is not possible stay sets, then we can use the strut. And these are the basic things for a line components. So these are the, now we are going to how many poles is required, how many stay sets is required, how many cross arms is required, how many pin insulator is required, how much of the length of the conductor is required. I am going to make a schedule. That is our aim today. So these are the things you should know. Now let us do. So materials required for a LT distribution lines. What we have seen here, the conductor, already you know the ACSR aluminum conductor, steel reinforced, ACSR means. Now insulators, pin type insulators and stain type insulators, cross arms, stay sets, earthing sets, dangerous plates and barbed wires, anti-clamping purpose, and miscellaneous cradle guard if it is a crossing in the road or railway track. Then we can use the GI wire, SW8 SWG GI wire, and so we require these things. Now before that one we are going to see the insulators, LT insulators. So this we can see the pin insulators, and these are the shackle insulators, and latest we are using the polymeric composite insulator. This is the latest one, silicon polymeric composite insulators are nowadays we are using instead of porcelain insulators. These are the LT insulators you can observe here. And after that, so this is a guy insulator where we are using this in stay wire, and this is also one shackle insulator. You can see this one shackle insulator also. So these are the some insulators required for LT erection. Now after that, cross arms, the flat cross arms is required, GI cross arms is required, and this ACSR conductor is required. Next, stay set is required, and so every fifth pole as per Indian electricity rule we require the every fifth pole should be earthed. This is also we have to done. So these are the things we should know. Now for example, estimation of power lines here. So I want this line to erect. Let us assume in my village there is no power supply. So away from half kilometer there is a 11 kV line. From 11 kV line to one DTR, from DTR to my house I require the half kilometers. I want to estimate the how many poles is required to supply the 400 volts from DTR to my house. That may be half kilometer for example. Then how many poles is required? This type of the structure is required. So let us do. So these are the lines, these are the number of poles is required, number of cross arms is required, number of insulators is required, and number of stay sets is required, and all are required. So let us do how many poles is required. Let us do our problem. Then so whatever the you given problem, first of all you assume that, so you remember that the span, what is the span? The distance between the two consecutive poles, that is the span. The span may be 90 meters, 80 meters, 60 meters, 110 meters based on the pole height, based on the voltage. Now you can remember that at starting, at ending, you should provide the compulsory one stay wires, supporting mechanical support, and every fifth pole should be earthed. Every fifth pole should be stay. You have to provide the stay, and in between we require the cut point also. That means cut point means it has a jumpers. So if required, I can open the supply circuit should be opened manually. That is the cut point also, whether it is H-type cut points or single pole cut point, by using the shackle insulators or disc insulators. These are the things you have to remember. So these are the LT line I want to estimate here. Now this end poles, you know. So you draw the line. This is the first is the source to feeder, and number of lines are the number of poles is required. Now steps for estimation of line. What are the steps? Already we have learned how to estimate the 11 kV line. Similarly, we are going to apply here also. The size of the all things are changes. The insulation property also changes. Now first, whatever the problem is given, first draw the single line diagram similar to the previous one. Now find the total number of spans. Span is the distance between the two consecutive poles. Then find the number of poles. Span plus 1 is equal number of poles. Now calculate the length of the conductor. So we will give the half kilometer. So half kilometer length. Then how many wires are you going to use? Whether 3 wires or 4 wires or 5 wires based on the given property. Then find the total length of the GI wire from. So we require the GI wire also at running along the line. And find the number of pin insulators, number of shackle insulators, strain insulators, and total number of cross arms and top brackets, and find the total number of stay sets, find total number of earth sets. These are the main things you are going to estimate. And how much of the material is required, what are its approximate cost for erection of this line. You are going to estimate this thing. Now prepare a schedule. All whatever you are calculated, prepare on a paper in a table, that is known as the schedule. Schedule will give the overall idea how much material is required, what is its specifications, how many numbers of this materials required. It will give the overall idea. To fill the schedule form, we require some calculations. So what are the calculations? These are the calculations. How many number of poles, how many number of spans, how many number of length of the conductor, length of the GI wire, and number of pin insulators, all things we are going to calculate. This is a very simple steps. Let us do one problem. Here single line diagram, we are going to draw this one, and after single line diagram we are going to, so whether it is sometimes they will give the cut point. So that is you can see the red color cut point. So here cut point is in this case we are going to use the stay wires extra, and disc insulators or shackle insulators. Here the two sides we are going to use it. At angle point also we are going to use the stay set as well as the strain insulators. These are the things you have to remember, whether the feeder is a straight, distributor is a straight, or some angle, it is going to some angle, then what are the precautions you are going to take. Simple. Now let us do one problem. Here what the problem is given? The problem is given that estimate the quantity of all materials required for laying 3-phase low voltage distribution line for 500 meters in a residential area. So half kilometers. The distribution line feeds both 3-phase loads and single phase loads including street lights. That means here the 4 RYB neutral in addition to one street light, the line which is the run above the top of the pole, that is the street lights. Now take at least one cut point. So he asked the one cut point jumper in the new line proposed. Assume the suitable span and data if it missed data. So this is the problem is given. Now based on this problem we are going to estimate the materials. Let us do. So let us assume what he missed the value. So draw the single line diagram as per his given concession. So how many poles, how many stay lines? So he given the one source and one is the cut point is the number of poles. How many poles we don't know now. Let us do problems. Now this is a feeder, this is the poles and this is the stay wires. Every fifth pole should be stay and every fifth pole should be earthed. So these are the things, basic things. Now let us do the solution. What are the assumptions? He asked assume the missed data. Then assumption is the span between the two adjacent poles is the 50 meters. We are assumed here. If it is given, okay. Otherwise, we are going to assume the 50 meters. Pole to pole distance is the 50 meters. Now here is given the vertical configuration of the line. So previously we have seen the horizontal R, Y, B and neutral is the cross arm is the horizontal. Now he is asking the vertical configuration. The pole, the parallel to the pole axis, there is a, we are going to provide the lines. Let us see here. So that is he asking. Let us, we can do, no problem. And here the conductor 6 by 6 by 6 and up 6 by 2.59 ACSR or AAA aluminum conductor is required here. Okay, 6 by 1.211 mm ACSR conductor is required. Okay, so now here what is happening, the configuration, you can see the tower configurations. So here first case the vertical stack. Now in this problem is asking assumed a vertical stack. So what is the horizontal line? Actually this extreme right is the horizontal, generally we are going to do, but is now it is assumed as a vertical stack. So R phase, Y phase, B phase and neutral, and top one is the street light. So these are the things we are going to do some. Now this problem is a sum of out of from routine problems. No problem, we can do here. Now you can see here. So normally the extreme right type problem is very easy to do, normal calculations, but now his assumption is vertical lines. That means here all pin insulators is placed in a horizontal line. Now so here in this case vertical is horizontal. So let us do, no problem, vertical configuration of the line. Now so similar to this one, you can see here somewhere wherever we require this space is not available, we can use a vertical also, similar to this one. Let us do. Now what is that? First thing is spans, number of spans. How we are going to find the span? Span can be calculated total length by number of, that is the span, the length of the span. Total length is given by span. How much is the span? Is length is given half kilometer, that is 500 meters. How much span? 50 meters. The 500 meters by 50 meters, we are going to get the 10, that is the number of spans. We got it. Now number of holes is equal number of spans plus 1. Already there is a standard one. So 10 plus 1 is equal 11. So now we got the 11 holes are required for erection of half kilometer. After that, so we are going to find that, so conductor. So ACSR conductor is already we are assumed. ACSR conductor for the phase wires. Here how much distance? Half kilometer, 500 meters into 4, R phase, Y phase, B phase, and at the same time we are using the street light also. So 4 lines except neutral, the 4 lines. So plus 4% of wastage and sag purpose, we are the 4% extra. So after doing this one, so we are going to get that 2080 meters of the ACSR conductor 6 by 2.59 mm ACSR conductor, that is the phase conductors. Now after that we are going to calculate the length 6 by 2.11 mm ACSR conductor for neutral wire, that is the same distance, half kilometer, 1 neutral into 1 plus 4% sag and that is thing. So after doing this one, so 500 into 1.04, 4%, that is a 520 meters of the ACSR conductor is required for the neutral wire. So now length of the aluminum wire, length of the neutral, we got it. Now next find the earth wire. So earth wire, what is the size? 8 SWG. Generally we are using the galvanized 8 SWG standard wire gauge. wire. Now GI wire for earthing is equal, distance is a 500 meters into 4% of the wastage, we are going to 520 meters. Now after that, insulators. Now we calculated number of poles, length of the conductors. Now number of insulators, we are going to find that. Now in this case, insulators, the different types of insulators, already we have known that under normal running condition we are using the pin type insulators. At end we are using the strain insulators, that is the shackle insulators. And so here we are going to use that. Here you can say LT disc insulators at cut point. At cut point we are going to use the specialized insulators, that is so here one cut point, R phase, Y phase, B phase is a one side 4 insulators, and R phase, Y phase and street light is the on the other side. The 8 one cut point require the 8 disc insulators is required for a cut point for the jumper purpose. Now LT pin insulators, normal pin insulators, R phase, Y phase, B phase and street lights. We are going to get the 4 insulators for each pole. How many poles? Total 11 poles. At end, at corner, at that corner we require the, we remove that one for the strain insulators, shackle insulators. Remaining is the 11 minus 2, so 9 into 4, that is called 36. Now LT shackle insulators at dead end place. So here we use the, at dead end only we are using the shackle insulators. That's a 4 into 1 by 4 shackle insulators. And next is the LT rail insulators for connecting the neutral. So that is the 11 poles into 1, 11 is required. Now here you can use the D type clamp. The cross arm, one cross arm is required at starting. So that is one start at we have to take the supply from the existing line. So that's why MS cross arm 1.52 meters into 75 centimeters, 37 mm, one number of the MS cross arm is required. After that, so we require the miscellaneous things. What are the miscellaneous things? D clamp for the shackle insulators. Shackle insulators we have to connect the at last. So at the end of the line. So D type. What is the D type? You can see here. This is the figure D type clamp. Now D clamp for the reel insulators for the neutral purpose 11 and stay sets. Next is the, we are going to use the stay sets to mechanical support. So otherwise what will happen, if comes a heavy gale and wind, then there is a possible to fall the lines. So to avoid that one, we are using the stay wires. So 2 at a dead end poles, 2 at the cut points and 1 at every 5th pole and 1 for the arbitrary at one place. So we are going to get the nearly 8 stay sets required. Now so we already calculated number of poles, length of the conductors, length of the GI wire, number of insulators, pin insulators, shackle insulators, disc insulators and number of stay sets, number of earth sets and miscellaneous also we calculated. And now based on this, these are the materials required. Now let us summarize these materials on a given paper in a tabular form, that known as the schedule. Now what is the schedule? First, serial number, specification of material, the quantity and remarks. Sometimes we are going to add another column also, cost. That is the estimation costing of materials. Now we are not costing here, only estimating materials. Let us do 1. How many PSCC poles? So here PSCC poles are the cement poles. This is the pressure, the cement concrete poles. So here 8 meters long. Sometimes we can use the, nowadays there is a 9.1 meters PSCC poles generally used. Next, concrete poles. Now ACSR conductors, it is the 2.8 kilometers, already we calculated. Next, ACSR conductor, for this also we calculate the for the neutral wire, so 520 for the neutral, and LT pin insulators 36 with the clamps. Next, disc insulators we calculated 8 numbers, LT shackle insulator 4 numbers at start, reel insulators 11 for the neutral, MS cross arms 1 at starting, and D clamps for the shackle insulator 4 numbers, D clamps for the reel insulators for 11 numbers, and top insulators bracket for the 9 numbers for the that one. Next, earth wire SW520 and cross arms 1 number and stay sets 8 numbers, knee bracing set 1 number and the earth wire clamps 11 numbers and binding wire 3 kgs. So require aluminum binding wire to bind the number of insulators with the poles. So that is the thing you have to. Now the binding wire is a 3 kgs and barbed wire 10 kgs. Lightning arresters 3 numbers is required. So lightning arresters also be required and at distribution transformers and high screw bolts and nuts 2 numbers, one at each end of the line. LT cable box with fuse 1 number at transformers. I think it is these are the optional. Next, cable also this optional and gang operating switch for the transformer and street lights fitting with reflectors 11 numbers for the street lights, dangerous plates for 11 numbers and cement and concrete is a lump sum and earth sets are earth sets 2 numbers, isolators 3 numbers at starting pole and bolt nuts for the various sizes 5 kgs and sandals like red oxide paints is the lump sum. So these are the some schedules we have made. So I think the accessories based on your options, whether you are going to use the this all things or main things you are going to add it. So I think you have the some idea what you have learned today. So regarding the problem is given the half kilometer LT line, the vertical configuration. So based on given span we are assumed a span of 50 meters. Based on given length, based on span, assumed span, we calculated number of spans, number of poles, length of the aluminum conductors, length of the neutral wire, length of the GI wire, number of insulators, pin insulators, shackle insulators, number of stay sets, and already we know that every fifth pole should be one stay set, at starting at ending should be stay sets is required. That is a normal thing as per IA rules. And earth sets also every fifth pole should be earthed. And what the next? And miscellaneous things. So these are all are written on a tabular form. Then we can say it is a schedule. So these are the method for preparation of estimation of LT line. I think you have the some idea how to calculate, how to estimate the materials for a LT line. Before that one, so we have seen all our power system, how the energy generated coming to consumer through different stages: primary transmission, secondary transmission, primary distribution, secondary distribution. What are the different configurations takes place, how the lines are connected in power system, in our distribution system also we have seen. I think you have the some basic idea regarding LT line distribution system. So based on this one you can do the remaining problems. Thank you very much for listening.